It's 1 o'clock. We'll get started right on time. Thank you, everyone, for joining promptly. I'm sure we'll be having others sort of trickle in over the next few minutes. Really excited to get started today. As we're waiting for those people to join in, for those of you who did just join, we have a starting question for you. So please open Menti on your computer or your phone. You can leave it open. We will be using it through today's presentation. And you can either go to the link in the chat, use the QR code on your phone, or menti.com with the code on the screen. And I'd love to hear, why do you as an energy manager want to improve your organization's energy metering? So from your perspective as an energy manager, why do you want better metering capabilities? I'll just give a minute for some of those people who are just joining to respond. And then I'll move on to the introductions. This is a chance. I'll come back to the answers for this question shortly, so it'll give some time if you're still going there, but please get that open for future use. All right, so thank you everyone for joining us today. We're talking with some experienced energy managers from our community about their experiences with energy metering and data management technologies. So I'm Jay Mullen from Goldfin Consulting, representing Save On Energy, and I'm really excited to have Jason, Jochen, and Max here from Plastcoat, City of Mississauga, and Saputo to share some of their experiences. I know this whole metering topic is something that keeps coming up of, how do we get better metering? What metering should we get? How do we get buy-in and support to improve our metering capabilities? So I'm really excited to hear about their experiences and to share that with yourselves. What we're going to start with is, for today, we're going to start looking at approaches to monitoring energy use. So this is going to be a quick overview, a bit of a refresher of what are these different options or ways you can approach metering. And the intent there is to really kind of frame it for the audience, get you thinking about where you are and these different approaches, where you may want to end up, so that when we get to our panel discussion and the presentations by our present energy managers, that you can think about how that relates to your situation and think of what questions you may have to help you move to the next step on that. They will be presenting case studies from their situations, and we'll have time for panel discussion with lots of time for questions and answers. So please, as we're going through, think about what questions you may have for our panelists. I'm going to go back to our question that we had to kick it off. So we asked, why do you as an energy manager want to improve your organization's energy metering? If you're new and joining, you can go to menti.com and enter the code or the link that Jackson has put in the chat. Let's see some answers. We can't improve if we don't know where we are. Right, the impact of the changes. So knowing where you're starting from, being able to see those impacts, being able to enhance engagement, great, increase our energy awareness, where there might be savings opportunities, visibility on energy use costs. Okay, these are all great reasons. Demonstration of results achieved from the actions taken. That's such a good, getting that feedback loop of, hey, you helped us do these projects, save energy. You can see the results. Can't manage what you can't measure. That's always one that comes up. Identify those areas of waste. Give plant personnel a better opportunity to identify and implement improvements. All right, so these are things that come up a lot from the energy manager's perspective. What we're going to do now to start off is we're going to pair you up with another participant in the breakout rooms. So if everyone could please turn on your camera just to show that you're ready for this conversation to be part of the breakout rooms, that would be great. And then in your breakout rooms, I want you to share why your organization might want to improve energy metering. So we had in Menti some answers of why you as an energy manager want to improve metering. Why might your organization want to improve energy metering? So I want you to share that with the person that you're paired up with. And then I want you to briefly discuss why the reasons your organization might want to improve metering might be different from the reasons the energy manager, you as an energy manager, want to improve metering. All right, so we're going to send you out in just a second. Before we send people out for this brief, you'll have about 6-7 minutes in the breakout rooms. The countdown timer is going to be in the top left. Is there anything I can clarify about these little discussions? If there are any issues or technical issues, you can type into the chat and we will see those. So we'll send you off now, and we'll see you back here in a few minutes. And I'm looking forward to hearing some of the ideas. All right, Fatema, you can launch those. All right, welcome back from your breakout room discussions. I didn't get to have the fun part of participating in your paired up breakout room, so I would love to hear about what you maybe talked about in your room about your organization's motivations or reasons for wanting metering and why those might be different from yours as an energy manager. Does anyone have any interesting points or insights come up in your discussion?
Okay, for myself, we've been pursuing energy savings for a while and throughout the corporation, and metering will be a good way to find new opportunities that we haven't yet identified.
Yeah, I mean, definitely, that's a great opportunity for using metering. And do you think there's sort of consensus on like you like as an energy manager looking for those energy opportunities and say leadership in your organization about wanting it for those reasons?
Yes, there's a good alignment.
Okay, great. That's awesome. Mike? Oh wait, I see there's another hand up before you, Mike. Sorry. Max.
I'll be quick. So I was with Parissa, who is the energy manager for one of the universities in Lower Mainland of BC, and we both sort of arrived at a similar conclusion for what the organisation wants. They want the big picture, so like the whole organisation level, for more sort of strategic planning. Whereas myself and Parissa want more granular, like individual buildings, or in my case, individual pieces of equipment, because we're looking for those opportunities at a tactical level rather than just deciding like what the energy budget for a year needs to be or how much of the overall available money that the organization has can be allocated to energy efficiency and improvements. That's kind of the sort of the decisions that the organization might want to do.
Right. So they're looking at those top level, like, okay, like dollars, are we on track for targets? How are we going to like get there? Whereas as the energy manager, you want those like really detailed insights to find those opportunities to contribute to those high level goals. Okay, I like that. Mike.
I just wanted to point out power quality as being one of those other benefits that is very important to us in a healthcare setting. It's I mean, it's not necessarily my primary concern on the energy efficiency side of things, but it's a really nice added benefit that I can push out there for others' benefit that helps sell the business case, even though it's not my primary interest.
Mm-hmm. And I'm curious in that situation because I mean that's definitely a big issue, particularly in some facilities, some sectors, the power quality issue. I haven't often seen like leadership or management articulate that like we want power quality on there. So is there like a bit of a difference in terms of the reasoning at their level?
Yeah, they don't necessarily realize they want it. They want reduced patient risk. And why did those pieces of medical equipment shut off the other day?
Right.
That's what they're seeing, but really it's because there was a brownout. It's because there was a power blip, and so
Right.
indirectly for them, I guess, even if they don't
But they want
realize
that like reduce risks, improve reliability. That's what they want there. Okay, cool.
Yeah,
All right,
yeah.
Senka.
Yeah, so I'm from Magna. One of the things we stipulated in our internal auditing is having meters in place. You can't manage what you don't measure, obviously. And a lot of things we're finding is a lot of our plants that have numerous, like we have plants that have over 300 sensors and meters in place, but their benefit is finding failure. So finding failure before it becomes critical. So a lot of cost avoidance with the meters.
So cost avoidance from the improved reliability, improved uptime,
yeah,
all that,
exactly.
the preventive maintenance side of things.
Yeah.
All right. That's great. So we had you go through this little exercise because I think a lot of times as energy managers, we're the ones thinking about metering and we want that metering capabilities. We want to see that granular data. But when we're trying to get buy-in, support, approval for purchasing these systems, for installing these systems, it's other motivators. And Mike, like you said, it's like there's a direct line connecting those things of like the power quality, direct line to reliability and reducing risks, things like that. But it's important to frame it in that way when trying to get support for these. So thank you everyone for participating. What we're going to do now is we're going to do a quick refresher on different approaches to monitoring energy. And hopefully this will provide some clarity as to where you currently are, a little bit of mapping of where you think you are, where you want to get to, so that when we hear from our presenters, you can relate to their experience to yours and ask questions of them to help you get to your next steps. Right. So while there's lots of ways to meter data with metering systems, you're going to generally need to follow the steps below. So you need some way to measure the data, whether it's power, flow, temperature, you need some kind of meter in place. You're going to need some way to collect and log that data. So this could include downloading the data, having a networked system. I've even seen like handwritten logs and even a webcam pointed at a meter that didn't have data collection capabilities. Those are not necessarily the best or most reliable means, but people make do in different situations. And finally, you're going to need some way to some processes in place to analyze that data, to gain those useful insights, and to communicate that data to the people who will use it to make decisions. So these are the kind of 3 steps that are going to happen regardless of the level of sophistication you have in your metering system. When we talk about those different levels of sophistication, it can be useful thinking about those, not just to understand where you are and what you want to end up, what you might consider that gold standard, but also how to get the most out of the system you do have now. And that's really important for 2 reasons that I typically see. One is if you get the most out of what you have now, that puts you in a really good position to get the most out of the better system when you get that in place. The other thing is it helps demonstrate the value of metering to those people who you may need support from to invest in a better system. So the first thing, most organizations start out with simple utility meter that measures like total electricity use, for example. And while this does have some limitations in terms of that granularity we talked about and the insights it can provide, it can also be extremely useful for understanding facility level energy consumption, trends, changes in energy use intensity. So these things, you can get a lot of value out of just the utility meter. So I think a lot of people are in that situation where you could improve upon that. The next level that we kind of look at is the use of submeters. So typically this starts off with just submetering some key areas or significant energy users within your facility. For campuses, submetering might be the first time they get just building level data as opposed to multi-building data. And the use of temporary submeters can be a really cheap, relatively affordable way to start getting data from different systems and start demonstrating the value and the insights that can provide to help build that support and save energy. And then the last level of sophistication we kind of consider is that energy management information system, or EMIS, which that refers to like a permanent system that automatically collects data from meters throughout the facility. Senka mentioned sometimes hundreds of meters within a facility, and it automatically brings all of that data into a central hub that then spits it out to dashboards or reports to show useful insights that people can act on. What I'm going to do now is I'm going to run through a quick example for each of these levels across those 3 steps. While I'm doing that, I want you to think about where you are, because we're going to have you kind of stamping where you are and where's the kind of like next step you'd like to improve on it. All right, so we have on the utility meters, a typical application of this would be, you're measuring it using that utility grade meter for the whole facility. You collect the data by downloading it from your utilities online portal, and then you use that data to update your facility baseline model. You share that with the energy team, the insights in terms of changing energy intensity, quantifying the savings. So you can get some use out of that. The next example, where with submeters, is you might have some portable clamp-on power meters. You can download the data directly from the loggers that are part of that meter, and then you can look at that interval data, that collected data, to identify trends or opportunities to improve the efficiency of that particular piece of equipment or system, and you can work with your operations or maintenance team to address those. And lastly, for the EMIS, you've got multiple meters throughout the facility. All of that's being collected through a wireless data collection system, as an example. And then those dashboards are going out to operators. That information is feeding into monthly, quarterly reports to management teams, and providing some insights and useful information on trends. So this is just some quick examples showing those 3 steps at different levels of sophistication. So now what I want you to do is we're going to open up the annotate window, and there's a stamp tool within that. So it's likely marked with a little heart, and you can click on that and you can choose some different stamps within that. I would like you to open up the annotate tool, choose the checkmark stamp, and put a checkmark on what you currently have in place. So if you're just at the utility meter and you're getting that data, but you're not really doing much with it, you may just have like the top left one checked off. Whereas if you have that EMIS system installed and it's collecting the data and you're analyzing and getting that data out to people's dashboards and communicating that well, you may have those, like that full bottom row checked off. Okay. This is getting a lot more crowded than maybe I thought there, but so I'll say we have people all over the map. So hopefully you remember where your stamp was. And interesting to see that we do have people kind of at all stages here. Okay, so we're going to clear this now. And I want you to pause, and then I'm going to have you find the star stamp tool. For those of you who are drawing, this is going to be a little more complicated if you're sticking with the drawing. So find that star stamp, and I want you to stamp the one area. So one of those squares where you want to improve upon, as you see as the next area to improve. So if you've got your utility meter, but you're not necessarily using it as well as you maybe could be, then maybe you want to star I see some of those in the analyze and communicate. If you want to upgrade to the next meter and get more meters in place, then maybe that left-hand column for sub-meters or an EMIS is what you want to improve upon. So we'll just give a minute for people to pause in. And again, it looks like we've got people sort of at all of those stages, a lot of them at the EMIS stage. Triangle, cool.
I added to both the analyze under utility meters and analyze under the EMIS because we want to be doing both in parallel for 2 slightly different reasons in our plants. And we're having trouble building monthly based, or with trouble building regression models at the monthly level using utility meters. And that's almost like a check mark for me as an indicator for if a plant doesn't have good control over their processes, they have a lot of operator type stuff, then that can show up in an inability to create a month level regression analysis. And then I'm not even going to bother trying to do anything at the EMIS level if my plant's doing everything.
So having different facilities, you may have like at different facilities at different stages of this.
Yeah.
And like different levels of cool. Does anyone else want to share what they see as that next area or why they chose that as the next area to improve? So the point of this was to get you sort of, as the audience set and sort of framing and understanding where you are in this. So we're going to stop the annotations there. And we're going to go back to Menti now. So we've talked about where you want to go to.
Jay,
a lot. Oh, go ahead, Max.
Jay, before you do, if you don't mind just jumping back a slide, I just want to make a comment that we're seeing from our industry, and it may apply to others in the next couple of years, is almost alongside like the EMIS, and it would either fit in parallel with it or either side of it, is collecting information in such a way that it has an audit trail for auditing for third-party reporting, and this is mainly around our carbon reporting, so the Carbon Disclosure Protocol and science-based targets. and to our shareholders, we need to have a system where we're collecting energy data, but in such a way that we can prove that it's not being meddled with and fixed and altered after the fact. And that's kind of different from the EMIS and these other things. And that's new. That's only in the last 12 months. That's really, we've really been paying attention to that.
And that's interesting. And also a good segue into our next Menti question which is, what factors or characteristics do you need to consider when choosing a meter or metering approach? So I think that's a really interesting one in terms of a new trend and having it as an auditable trail in place there. For those of you that joined a bit later, you can go to Menti following the link that Fatima dropped in the chat, or you can go to menti.com and use the code at the top of the screen on your phone or your computer. So I'll give a minute just to hear this. And I'd like to think about, for those of you that are looking to upgrade your meters, get some more meters installed, or possibly looking at EMIS systems, I'd like to hear briefly what are some of those factors or characteristics that you're needing to consider. So integration with the BAS? Yeah, definitely. I think that's a big question. How do we make sure that this does integrate with our existing systems in other areas? Network security. I feel like that one's definitely another one that's coming to the forefront in the last little while. Cost benefit analysis, the type of data input, whether to do interval versus continuous, and dollars. All right, so we got a lot of, are things compatible? Do they integrate with what we have? What's the cost like? Revenue grade meter, like how the accuracy of those meters. Do you need a meter that is like revenue grade accurate, or is a lower level of accuracy okay in your situations? Okay, what types of meters, how reliable they are. I know there's been a lot of, I've heard a lot of discussions around, wired systems versus wireless systems, and having challenges with reliability of wireless in connections in some facilities. The ease of installation, portability, great. Calibration, how often or if they need to be calibrated. Another one that I haven't seen here that is a bit more sector specific, but there's also some instances with ownership of meters. And when you get into situations where there might be like tenant versus building owner or facility owner in place as well. Okay. All right, and how that data is coming in. All right. The next question we have is, those are good considerations for it. Now I'd like you to rank what you see as the biggest barriers or challenges that you're facing in improving your metering system or how you're using your metering system. What do you see as the biggest barriers, the top barriers, when it comes to improving your metering? All right, got some answers coming in. Selecting the right one, the costs, system integrations, data security. Got some common ones coming up there. I always like this. It seems like a little bit of a horse race where they're it's like, oh, and expertise on staff is coming up from behind. It's interesting. It's interesting to see too that with all the talk of like, there's a lot of talk in terms of like new affordable meters coming out, but that cost is still one of the biggest challenges or barriers to implementing systems as well. All right.
I think with costs, it depends on what you're trying to meter. If it's just simple electrical meters, then the costs are really low. But for actual like process meters, anything where you're measuring flow, the cost can get quite considerable, particularly the installation cost. And then it may not necessarily be the cost of the meter itself, but the cost, like you said, Jay, around the Wi-Fi versus a wired connection. If a meter is on the other side of a building, away from where you need that data to go to, your cost of your wiring can be 3, 4, like multiples of the actual cost of the meters themselves.
Yeah, so it's still, and I saw the comment from Joan as well that it's not just the capital, it's the ongoing operating costs of this. Okay. So thanks everyone.
I've had so many of our meter quotes where the majority of the cost is in the installation cost rather than the meter.
All right. So thanks everyone for participating in that. Hopefully the purpose of this was to kind of like set the stage of some of these common challenges. What are people looking for? How do you figure out how to get to that next step and the barriers to getting there? Now we get to hear about some of the experiences from energy managers in our energy manager community. So they're going to give a brief presentation about where they started from, the type of system they've installed, what it looks like, that kind of situation, how they use their systems, and then we'll get into a panel discussion with a bit more questions around how did they get there. And what did that look like? What were some of those lessons learned? So as they're going through these presentations, think about what questions you might have related to your own situation to help you sort of sort out what might be next. And you can use the Q&A panel. You can open that up at the top of the screen and add questions that you might have as we're going along, and we'll get to those. And one of those questions for us to think about is everyone has a question about, for those with an EMIS system, comment on those ongoing costs and resources as part of this. And Joan, we are recording this session as well. So we don't have to get to Edwin's question now, but guest presenters, panelists, let's keep that in mind and make sure that we do touch on that point, because I think that is an important one through there. So today we're very lucky, I'm very excited to have Jason Barber from Magna, from Plastcoat within that, Joe Chu from City of Markham, and Max Maxim from Saputo to share some of their experiences. So I'm going to pass it over to Jason first, if you want to get started. Welcome.
Thanks, Jay. Okay. Good afternoon, everyone. As Jay mentioned, I'm Jason Barber. I'm the Tooling, Health and Safety and Environmental Manager here at Plastcoat, we're a division of Magna International. We are a little bit about the company. We're an automotive parts manufacturing facility for those that aren't on here that are not part of Magna already. We're an injection molding plant, so we mold plastic automotive parts and assemble them and ship them out to the OEM. So we began our power monitoring system based on a need to reduce utility costs and improve equipment reliability. We also needed a way to measure and justify our energy improvement projects. Okay. So next slide, please. Okay, so our journey began kind of using these simple handheld multimeters that would log data. So we used those to try and measure the electricity to justify a project. From there, we kind of evolved to more of a live data power sensor. So we started with the main meter, as Jay kind of talked about earlier in the presentation. So started looking at that main meter live, and then we continued adding smaller individual sensors on pieces of equipment to evolve our system. So this little picture down here at the bottom shows, today we've evolved to more than 520 power monitoring sensors, as Sanka kind of touched on. And what we do is we have this sensor that clamps on a power meter, sends a wireless signal to a receiver, which goes to the cloud, which then goes to a data monitoring screen or dashboard. Okay. Next slide, please. All right. So the power sensors that we use come from a company called Centrica Business Solutions. They call them Power Radar sensors. You may, if you're looking into it, you may also hear Rentechnic as the company. So as I mentioned, we started with the main meter. We did try quite a few different sensors and different companies as we got into this, and we settled on these ones, kind of the simplicity and cost and the software that went along with it. So after our main meter, we installed all the small ones, and that breaks down the power used to kind of our main areas of equipment, and then more sensors at each one of those to break it down further for individual points, which may be like a motor or a heater or even something like a light. And as I mentioned, that data then is published onto the dashboard. And at that dashboard, that's where we'll have our charts and reports that we'll review and talk about. Also allows us to do a deep dive where we can go through each of the individual sensors and see kind of what's going on. We also have the opportunity to set up, alarms or tolerances to trigger those alarms. Okay. And next slide. So this is an example of kind of what we have today. We have the live data posted on dashboard. It's available on computers, phones. It's displayed on the screen in the middle of our production area where people can go and see it and make decisions. We're using it for our weekend shutdowns. You can see where the exact total use is, what's maybe on or off. We can look at equipment during idle times, make sure what's off or what's should be off is off. We also look at it for predictive maintenance. We can see if our equipment's running efficiently. We can see if things are starting to degrade. In times of failure, we can look at it for that analysis to start pinpoint what's going wrong. And a big win is for energy projects. We've already got the data when we start to justify those. Next slide is kind of where we've moved on to outside of the power and beyond as a full energy spectrum. We talk about utilities monitoring here as wages. So water, air, gas, electricity. Out there in the industry, you'll see it as steam. We adapted it to silos because here we use a lot of plastic resin. So that's what we're looking at there. And you can see we've got all the charts and metrics that we look at with the teams for all of those. Okay. Next slide. And last, Senka touched on this as well. The big win for us and a takeaway is for our predictive maintenance. So using that power, we can see power spikes, abnormal changes, and it maybe an increase in power or an incorrect use. We have here a lot of aging equipment or older equipment where we were maybe plagued with breakdowns. And we wanted to get ahead of it, be able to predict those downtime events. So those sensors allow us to identify those problems. And in this graph here, you can see where the equipment is off. That's that flat line at the beginning. And then there's a big power spike before it comes back down to a normal running point. So that big power spike, when you go back and look, easily seen, you can figure out what's going on. So instead of our team doing a soft start like they should, we can see that they were not following a process, and we ended up with that big power spike, which can fatigue equipment. So it allows us to go back and make corrections. Okay. And I think that might be my last slide.
Yeah, I think so. Thank you, Jason.
Thank you, Jim.
All right. Moving on to Jochen from City of Markham. Welcome.
Yeah. Hi, everyone. Yeah, so just an introduction. My name is Jochen. I'm from the City of Markham, as mentioned. In my role here, I'm the lead on our citywide metering program and also the lead on measurement of care verification for any projects that we implement. So I'll start with what we have right now, or what we had originally, starting a couple of years ago. So throughout our numerous facilities, we had a number of facilities sub-metered, but also whole building meters on meters supplied by Electra. We already had the full building meters on a single platform. So there's one login that we can get into and see the monthly data, at least from all our buildings that have meters on them. And that includes electricity, natural gas, water, and district energy. But our more granular data, if we want to get into hourly that was spread among a number of platforms. So all our sub-metering was, there was no real strategy in place before, and so whatever was installed at the time was put in, and we have some issues with that. So the biggest one is because they're accessed separately, it's kind of inconvenient. Keeping track of what facilities are on which platform, and also just keeping track of the logins and how to get to each one. Each of the platforms also had different capabilities and how they were able to show data and manipulate it. And kind of final issue with that is training other staff on how to use it. When staff with a turnaround, or if staff maintain multiple facilities, we have to update the training and make sure they were able to use some of these platforms to access the data should they require it. And so our goal in the end was to try to consolidate our sub-meters to a single platform. And so that began our journey into researching what was out there and finally deciding on what we ended up going with. Next slide, please. So looking at different platforms, speaking with other municipalities and other organizations, we found that many of the platforms that we came across had many similar features with respect to the ability to view and analyze and download data. So we didn't really find that there was that much difference between one company and another in terms of being able to show us the data and provide reports that we were interested in. But we did find that the biggest barrier for us with most of these was cost, mainly with the operating costs and not so much the upfront cost of integrating the meters, but more so many of them operate along this model, a subscription model where you have to pay monthly based on a number of points. So we've thought that, as we expand this and add more meters to the system, add more points, it's going to cost us more and more. And there's no end to the cost based on the subscription. And so, and once you don't pay for the subscription, you don't have access to that data anymore. So what we ended up doing was integrating our meters to our existing BS platform that we're consolidating all our buildings to, which was Delta and Teleweb. They have a feature that they allow integration of meters to the platform, and so you can view your BAS and your meters all in one place. And it's not necessarily limited to electrical meters, because we are going to and plan to integrate BTU and water meters to it as well. And some of the pros of this that we found was, the biggest one was there's no subscription fee. We pay kind of one fee up front, and then in terms of ongoing fees, it's just some cost to the controls contractor to integrate any new meters to the platform. But there's no constraint in terms of how many points we can put on there. The data stored is all stored locally on our own server, so we own the data. And our ITS team likes that for security issues. And the platform is web browser based, which a lot of our facility staff like, because they're not always out there. Computers, when they're at the facility, sometimes they're using tablets or even their phones, and so they can access it that way. I would say some of the differences I noticed between this and some very dedicated energy management software would be the features it has. I think it's sufficient for us, but for some others, they may not feel like it's as polished or it's as easy to use. For what we use it for, I think it's completely fine. And especially for what we're paying for, I think we get what we need out of it, and we don't really need anything more than that. So at least for that, it works for our use. Next slide, please. So I think I made a mistake with the text here, but really what I want to show was just some of the views that we have with our Intellibot platform. And so this is just an example of one of our sub-meters at one of our facilities. It shows, these are just some sample views, but the first one is showing just hourly electricity consumption. And so that's kind of as granular as you can go if you want in terms of what the meters are able to show. And then the second one is more on a monthly basis, day to day, how the unit in this case is performing. So if there's one day that you use more energy than the other, it would highlight that in a different color and you'd be able to see it. I don't think it's shown here, but because we've only had it operating for a year, but also if we had it operating multiple years, it would be able to show you a comparison between how it compared the same day this year to the last, and highlight it that way. And so we found this, some of the things we've used it for so far are just identifying some opportunities for optimization. For example, we had one of these meters on a lighting panel at a facility and noticed that there's some hours that were quite high that maybe the lights should have been off, and so we investigated our lighting control system and found some issues with it there. And so that's just one quick example among others we've used before. Next slide, please. And this is just another one. This is one example of a report we've set up. There's many reports that are available and customizable as well. And this just quickly shows a quick comparison for a certain week of how these rooftop units at one facility compare to each other. But again, we could have easily set this up as a whole building comparison between one facility to another, or maybe one rooftop unit at one facility to another. Or there's just a number of ways you can customize these, and this is just one that example of one that we've set up. Next slide, please. And so where we're going from here is we've only migrated a subset of our meters to IntelliWeb so far, but we're going to continue with that. And our strategy for doing that is, as our building automation systems come to end of life, they're being upgraded to IntelliWeb, and so we're going to include any sub-meters at those facilities as part of the upgrade at the same time. But in addition to that, any meters that we purchase in the future, we're going to ensure that they're BACnet ready, and that just makes it easy to integrate to IntelliWeb. Some of the meters that we had in the past existing were only communicated using Modbus, and so to integrate to IntelliWeb, it was not difficult, but there's an extra step adding the gateway, basically translating the Modbus to BACnet to make sure it can communicate with the BS system. But because of that, we designed metering standard to make sure any meters we purchase from now on are going to be able to integrate easily and fulfill our metering requirements as well. And I think that's everything I have. Thank you.
Great. All right. Thanks, Jochen. That was awesome. And last up, we have Max from Saputo. Welcome, Max.
Hey guys. So I'm with Saputo. Our organization is one of the biggest dairy producers globally. We've got operations in 5 different countries, and we've got over 60 plants. I'm in charge of delivering our resource efficiency program, which is essentially trying to reduce the amount of water, gas, electricity, and waste for every ton of product that we produced. We've got a lot of sub-metering in our plants already. One of the biggest challenges is making the best use of that sub-metering and the information we have available. So we've used EMIS systems and dashboarding in various forms in different places. And this particular project that I'm going to talk about, and one of our approaches, was we wanted to compare a third-party solution with doing something in-house using SAP, the Enterprise Resource Planning software, because we were using SAP anyway at our manufacturing level to gather gather information on which equipment was running and when. Manufacturing execution system, I think it's called. And it turned out that there was because of the license that we were already paying for that, they had an energy monitoring analysis module. The only thing that we needed to do was connect the dots, basically connect our existing sub-meters with the SAP interface, and then build the dashboards and the way it's going to collect. In principle, that was simple, and would open up all these different sort of business cases. This was the reason why we did this project. We did a pilot project initially to just prove that it was possible. I will say I was very apprehensive about using SAP going into this project, because I'd heard that it can do everything, but it can't do anything well, because it takes a lot of programming and effort. But the big difference for us was having a very experienced and qualified IT team in-house to do that side of it. Where it fits within, where the EMIS and the metering fits within sort of our overall strategy, we look at it in terms of sort of assessing a plan to get the benchmark, idea generation, then prioritizing, evaluating those ideas, and then executing on those and implementing them. Supporting that is where the EMIS fits, the technology layer, the solution, the system, as I call it, and all the sub-metering within that. And then that allows the monitoring, targeting, and reporting, which is obviously the ongoing looking for fluctuations, spikes, and alarms. The two parts that fit with this is, as part of our sort of assessment, general assessment and benchmarking within the plant, doing a meter gap analysis is critical. And then within looking at the EMIS technology is an EMIS readiness map. This is basically taking not only the sub-meters, but what systems are in place to collect that data up, and then whether we've got the people on site with the necessary experience and time to do it, and whether the plant actually has the resources to allocate that person's time, but also the money available to implement it. So there's those two parts before you can kind of move, before you're able to move forward with taking the existing sub-metering. When we did this, we chose a plant that had a lot of sub-metering already in place. It was one of our plants with one of our better controls and automation experts on staff, and it was already connected to SAP and had that foundational layer of technology. And I'll show you a slide showing that in a minute. The process for going from a bunch of disparate sub-meters to a system where we can actually see it in a dashboard is a bit like this. So there's the things that you do, the dark blue is the things that we had to do sort of up front, system mapping, which major pieces of equipment like boilers, air compressors, and etc. we have in a plant. Then the sub-meter gap analysis, what sub-metering did we have on each of those systems, where there was a gap that we needed to buy and install new meters, and we had to prioritize what we chose because we didn't have infinite funds for this. And then we also look at the qualified personnel. Like, do we need to, if we're rolling this out to more plants, do we need to hire somebody or just move somebody from an existing plant, or do we need to do training? From that information, there's a set of, I guess, documents that we needed to create in order for the IT team, or if you were going with a third-party EMIS provider, that they would want to have to make the implementation seamless. We found that regardless of whether we are doing an EMIS implementation to take the sub-metering data and make it visible, whether we're doing that internally with SAP and our internal IT team, or whether we're doing it externally with third-party contractors doing the bulk of the gap analysis, doing all the connectivity, and using a third-party EMIS solution, which we do in some divisions. Regardless of which approach, the main challenge is having somebody on site who can marry up the data tag list and the metrics list, essentially all the little communication nodes, the connectivity to make the sub-meters talk to the system. That's the biggest holdup. That's the biggest challenge, and there seems to be a lack of people in general available to do that. And once you've got that, then it's just a matter of creating it and connecting it and configuring it. In terms of what we were looking for and the data we're collecting and the sources, we have KPIs. So there's a raw data collecting. We want to collect not only the energy data and the electrical data, the gas, we want to be collecting data on the stuff that's driving it. So our production numbers and the weather data. And we want to also have other stuff in more general sense, like compressed airflow as well, might be something we're looking at. So we can always turn our electrical data into some sort of intensity metric. So electricity used per ton of production, electricity used per cubic meter of compressed air we generate, or tons of cooling or pounds of steam we made. And then from the collected data, we have calculated outputs. I will say with electrical metering and submetering, one of the hardest things to do was to educate the folks doing the dashboard programming and the programming of the aggregation from the submeter, because a submeter can often measure data like every second, but if you're transmitting data every second, you're going to very quickly fill your data storage, and it's going to cost you a fortune in data storage. So we might aggregate it every 5 seconds, every minute, every 15 minutes, and trying to explain the difference between aggregating for kilowatt hours versus kilowatts and what that looks like was painfully frustrating, but I think we got there, and I think I've got a method to do that in a simple way going forward. So just something to be aware of. This is the platform that I was talking about. So below the gray line is everything at the plant level. So every line or piece of equipment would have a fuel meter, a water meter, and an electrical meter. We have multiple of those, and they feed into a manufacturing control layer, or the SCADA layer, which typically, this is where that aggregation is taking place. So the meter is going from 1 second, but we're actually saving the data point every 15 minutes or every minute. That's getting done at the SCADA layer. And then where the configuration, where I was talking about having the expertise to connect the dots between your dashboard system and your submetering system, it's this configuration layer and getting everything, all the IT systems to talk to each other in the way they're supposed to. And we have data coming from our ERP system, which is the driving variables of production. Also, weather would come in under sort of KPI framework, as well as the raw energy data. And then the dashboard solution is the EMIS, or in our case, the SAP EMA. And then the success factors, we determine whether it's a success or not based on our ability to now get real-time data versus just using monthly utility bills, so we can act on spikes and alarms in a more timely fashion, and the ability to reduce the time it takes to collect data. It's now automated. We don't have an operator going around manually taking meter readings, and it also automates a lot of the analysis that the plant energy managers and myself have to do. And then the other two, the bottom items, are also very important, like creating actionable insights that the plant manager and the plant personnel can use to drive improvements, and also increasing the ownership and engagement with energy management at the plant. When they can see something and they can see the changes, then they tend to pay more attention to it and want to find opportunities to then see the changes happening in front of them. Thank you.
Thank you, Max. So now what we're going to do is we're going to open to a bit of a panel discussion, Q&A with the panelists. So please, if you want to raise your hand or put the question into the Q&A panel or the chat, that would be great. One question that I had come up listening to all three of you is, there's interesting, you made points about your existing situation or your needs, and that influenced the decision. So either like, hey, we were already using this kind of system and we wanted to just expand our use of it, or we understood what our needs were, so we didn't need a fancier system. So I was wondering if you had any tips on how people might get that good understanding of what is your current situation, what's already in place, and what are your actual needs for this system that would then inform decisions around, you know, this metering system that you might be choosing. I wonder if you had any tips on how you kind of like assess like your baseline, what you've got, and what your needs are for this.
I think one of the key things to start with is doing an asset assessment or a site profile. You want to determine which are your major energy or electrical consuming systems or pieces of equipment. You may know that just from the size of the pieces of equipment or how many air compressors you've got and how often they're running. But you may need to put some temporary clamp on meters for a period just to get that insight. Once you've got that, that's then your starting point if you're wanting to determine where you want to prioritize putting additional sub-meters and going forward with this.
Jason or Jochen?
Yeah, I'll jump in on that. I think that's a great question, Jay. A lot of times I get, asked from other divisions or other people, okay, I'm supposed to be monitoring. Where do I begin? What do I do with these monitors? What are these sensors? What do I do? What's the point in this? And I think it's very important to know, what you're trying to accomplish, right? So one of the basic things for us is, we set a metric. We want to reduce electricity by 10%. So if the goal is 10%, we're looking at that electricity and looking for that 10% or little bits and pieces to reach that 10%. So I think it's really important for any sensoring, any monitoring to really understand what you're doing, or you just get into data overload. I see a lot of people throwing sensors everywhere, and I got all this data. What do I do with it? So it's really important to focus in on what your goal is.
Great. And Jochen, any tips from you?
Yeah, it's I think it's one question I've been asked a couple of times before is do we need sub-metering at this facility? And I think you have to look critically at, well, what do you want to do there, and how big, maybe even how big the facility is, how much energy it consumes. For example, the most recent one I've been asked it was that with pertaining to one of our fire stations, because we're doing major retrofit there. But if we look at it critically, the energy consumption there is not that high. We'd be better served installing the sub-meters at one of our recreation centers or large community centers where the value for the meter and sub-metering is much higher. At a fire station, the energy consumption is pretty low. The systems there are not that complex, and there's not that many of them. And so I think the whole building meter in that case is pretty sufficient if we can get hourly data out of it. But again, with the interval sub-metering, we find more value at some of our larger facilities when there's a lot of systems there, and we're trying to pinpoint maybe which ones are consuming more than others, rather than some of the more simplistic buildings, which doesn't provide much value in having sub-metering.
Okay. Excellent. I do have a follow-up, but there is a question from Edwin in there for Jason that he likes the WAGES acronym and asking what are the sensors monitoring on silos, and if there's any observations from that area for management or other departments find useful.
So for the silos part, again, that was a change for us. If you look in the industry, it's steam, but we're looking at our silo levels, and kind of that idea is to put that data in the hands of the users, so the people that are looking at the silos can see that live and make their decisions based on that live. Anybody who's using resins probably already has some type of monitoring. Ours was more just getting that data out there where people could see it and use it. Okay. Hope that answers the question.
Yeah, great. Thanks, Jason.
All right. Going back to your answer from the previous one of understanding what those needs are and where to go from there. A lot of your answers mention of, getting that starting point, getting some data or understanding those uses and kind of building on that. Are there any tips for people who are hey, we're getting we're not at a full EMIS yet, but we want to get some sub-metering in place, ideally kind of building up our sophistication in that line. Do you have any tips in terms of how to do that in a way where they don't then get to, oh, now we're going full EMIS and we don't scrap everything we did up till now because it doesn't fit with our new system? So that they can sort of build up to that a little bit more. Any kind of advice or thoughts on that?
I think the one piece that I would give, and I think it might have been Jochen touched on it, which is where the data is being stored. Any sort of sensor or meter, is it going to be stored on the meter itself? Does it need to be sent somewhere? And I'm probably jumping ahead a bit at the point where it's like looking at an EMIS system. But if the data is being sent off-site and held on a solution provider's servers, then that's a concern. And the connectivity of meters, its ability to interact with a whole bunch of different systems.
Jason or Jochen, thoughts on ensuring that those initial efforts are going to be compatible with your end goal?
I think for me, I would suggest before you get a whole lot of sub-metering installed, it might be better to see what's, like if you're managing multiple facilities, it might be better to make sure you have all those whole building meters installed first, the ones that are available to you from your utility provider, and try to make use of that as much as you can. And I think if you're using those, you find gaps that, oh, I wish, if you see like, oh, I wish I had more visibility into this particular building for whatever reason, I think that's when you start investigating and implementing a sub-metering system there. I think kind of blindly installing sub-metering systems, like I've seen, before I started here, there's a number of sub-metering systems installed. And some of the buildings we have sub-metering at, I'm like, I'm thinking, we don't necessarily need that here. Why do we have to install it there? And so I think, and now we just have these meters there, but we're not necessarily using them a whole lot because it doesn't provide a whole lot of value. So I think starting just at the highest level and seeing where the gaps are, and then dialing those in might be a better way to go rather than go straight into the sub-metering. Because for some organizations, maybe that's not even required. Maybe the full building meters are sufficient depending on how big your facilities are or what you're monitoring.
Okay. Jason?
Yeah, sorry. I think for us, we're kind of looking at it like a flow, as opposed to just throwing a bunch of small meters on. So I mentioned starting with the main meter and then breaking it down from there. So each one of our energy users are kind of looked at as a package and in that way. So even as we start to put it all together into that EMIS type of system, they kind of stand on their own, and then we're using our internal team to create that software that can kind of calculate the two together, as opposed to try and connect one system to another later on. So again, what's that first goal, or what's the plan, or what's the direction, and then we can put it together at the end. If that makes sense.
Okay.
I would also add that definitely look at what existing instrumentation is on any equipment and systems, as you may well find that in many cases there's something you can tap into that's already there, not as a separate sub-meter, but just within the normal controls or something. Like a new air compressor these days will have a lot of that monitoring built into the controller. It's just a matter of finding where it is to pull it out and visualize it in a different way. And VFDs is another example. You often have the power and total consumption tracked on those.
So looking at equipment or even some of those early sub-meters, that making sure that they have that output capability, that data can be brought somewhere off of just the local system or piece of equipment. We have a couple questions for Jochen in terms of asking if you could elaborate on your in-house metering standard and if there were any challenges in integrating the sub-meters into IntelliWeb.
Metering standards, it's kind of just a combination of specifying some accuracy requirements that we have, and then just some communication protocol and making sure that it can communicate with our BA system. It's not overly complicated, but it did take a little time to develop, but it's just it was developed just based on looking at a couple of referencing things other municipalities have used, and then some specifications that we've used on our own in the past, but just kind of narrowing it down a little bit rather than making, like I said before, like with the metering standard we had before, it wasn't the biggest thing. I think it wasn't specifying like that to communicate using BACnet, and so we had all sorts of meters and some that now we are having a little bit trouble or more trouble integrating to our VS platform. But in terms of the integration, like the ones we've done so far have been pretty straightforward. I think if you just talk to your control supplier, usually they'll visit the site and they'll be able to come up with some sort of solution as long as it communicates using Modbus or BACnet. It should be pretty straightforward.
Okay. And we have a question from David of how are you verifying that the data you're getting out of the meters is correct and accurate, especially process measures like chilled water or steam BTUs?
Guess I'll speak for Plastcoat. I don't hear everybody else going yet. So yeah, so for for the electrical meters, we're having our electricians. I think it's very important to get those kind of key people involved in it. So our electricians will participate in in that setup, that initial setup, and they're doing the calculations and verifying that everything's accurate. And then during our kind of daily monitoring, weekly monitoring, we're seeing if there's any changes. And when we're seeing an alert for something that's out of tolerance, we're also verifying it. And that kind of thing would go the same for whether it be air or a level sensor or those kind of things. They're all getting verified by that same kind of means, right? So a temperature sensor, you can do it with a barometer or an inline sensor. A lot of our I'm going to call them live data sensors are just mimicking that, for hydraulic pressure, it's mimicking that hydraulic gauge that's there, or like you mentioned, it's already there on the machine. So you can, double check and verify everything that way.
I would say for us, we're not doing it as well as we might. In many cases, for the use case that we're putting the information to, it's not too important exactly what the steam flow or exactly what the water flow or the temperature is, as long as we're seeing the trends and the movement. And so it's trying to determine if there's drift in the meter is probably more important than exactly where the meter is in terms of how accurate it is to start with. But in some cases there's been cases where we'll put a second meter in place and we will calibrate against another flow. So if we had two flow meters that were in line, we would take a clamp on meter, we would measure one and then measure the other, and if the difference between the clamp on and the inline meter is the same kind of difference in each case, then we're kind of happy. But if one of them is, say, 10% difference, but the other one is 50% difference, well, then we're like, okay, we're going to start questioning that one or the other, and we'll start investigating that a little bit further. Typically, we have an idea that a meter might be drifting out because we start to see process control issues if we're using the information from the meter for controlling our process.
David, I see your hand. Was there anything you wanted to add to that?
Yes, I was just trying to get clarification on situations where, number one, the meters from when they were installed were wrongly commissioned, and so you don't even have, like, even if there's a drift later on down the line, it's already on a faulty basis, so you're not getting the right reading either ways. And for chilled water, you can put clamp on meters. I don't know how you put clamp on meters for steam, and that's kind of what I kind of want to know. How do you do this verification? Because at the end of the day, you can be getting data, but if the data is not correct, then you're not making the right decisions. You're assuming your building is using so amount of energy when you're not really using that amount of energy.
So I can address that. So I've yet to see the results, but we are investigating some clamp-on steam meters at one of our facilities. And you've actually reminded me that that's one of the things I need to follow up on to see how effective they are. But apparently there is some reasonably good clamp-on technology for steam. And with steam particularly, one of the approaches we have to monitoring the output of steam is we'll look at a mass balance on the boiler. So if we know how much water we've got coming in and our blowdown rate, we can actually look at the volumes of steam that's going out, and then the temperature on the steam line is easier. And so knowing the volume and the temperature, we can kind of sort of back calculate the numbers that way. It's not as nice as having an actual steam meter inline, but that's an approach that we often use. I shouldn't say often used. It's an approach that we have used when we wanted to verify this.
David, I see your hand. I'm not sure if that's an additional follow-up or if that's just left over from before. We had another question before, is if the panelists could comment on those with an EMIS system on those ongoing costs and resource requirements. I think I've heard from some instances too where they kind of find it's like anytime they want to make any little change or update or add a meter in, that those costs really can add up. So I'm curious about your experiences on what does the cost and resource needs look like on an ongoing basis.
I'll just quickly say for us, we see the cost as the license fee cost. Then often there's a per data point or what's called a tag fee, and that can just be a couple of cents per tag. But when you've got thousands and thousands of tags, it quickly adds up per month. And then there's sometimes costs around dashboarding. If the system is not particularly user friendly, then we sometimes have to go back to the third party. But since looking at an internal solution and using SAP, those costs disappear because we're already paying a massive license fee for SAP in general for all of its other functionality, and the EMIS functionality is just a bolt-on freebie. And then in terms of the tag costs, there are now some organizations and some solutions out there where they are just going on a license fee basis. So you might pay more for the license fee, but you have an unlimited tag cost. Something to bear in mind though is that even if you've got your license and your tags, the data has to go somewhere, and there's always a cost associated with the data storage, whether you're paying the solution provider, your EMIS solution provider, to find and subcontract out that data storage, or you're paying for the data storage. That's also a really big cost.
Jason and Jochen, any other comments on those ongoing resources or costs on an EMIS?
Yeah, so as far as subscriptions or service fees, we don't have anything really like that at this time. It's all internal. We do have the storage fees, of course, for cloud and that type of thing. We do have our internal teams that are supporting it, so we do have some resources costs, but we tried to build that into our internal resources. So like I mentioned, getting our electricians involved in the power monitoring, getting the mill rates involved in the mechanical type stuff. So to try and build it in the teams as already users and maybe create them more of a specialist on that monitoring.
Right.
For us, I think the ongoing fees, we don't have any subscriptions or anything like that. Like I think I mentioned previously, there are some costs associated with when we want to add new points and meters to the system, but those are mostly just costs for your controls contractor, and it's like a one-time thing when you integrate it, and so it's not necessarily ongoing. I guess the ongoing one is as the others have mentioned, like if you're storing data on your own servers. There's a cost associated with that. I don't necessarily know what it is. Our RTS team deals with it, but yeah, there's certainly costs for that.
Okay. One thing I think in all your presentations, you'll get some good insights into those considerations that went into your decisions of like what system you would go with that was right for your needs. But I'm curious of when you started with that implementation, moving forward with it, were there any surprises that kind of came up along the way?
Yeah, I would say one. Hello?
Yep.
Oh, yeah. I'd say one of the surprises for me was that the sticking point being not so much the cost and the identifying the right technology, but having the expertise and connecting those dots. Whereas on paper and when describing the workflow, it seems really simple to make your submeter communicate with your system, but getting that done in practice, regardless of whether we're using a third-party solution or our in-house solution, that can delay a project by months and months and add the cost whilst you're going back and forth and trying to marry it up and trying to work out why something's not communicating. It's because they just don't matching up the codes. Just going back to the previous comment about the cost of systems, we started off with a third-party solution where we were paying on a per tag basis, and we were still using that in some divisions. That's really good, I think, where you've got a smaller number of sub-meters and a lower demand for granularity, and where you're not big enough to have an in-house sort of IT / development team to support it. We've sort of hit that level of size where that makes sense, and being an industrial processor, we've got a lot more data points than if we were a municipality or an institution, where I think just going with an off-the-shelf solution and paying for it would probably be less headaches and less cost in the long run versus trying to do it in-house.
Mm-hmm. Anyone else want to share any surprises or challenges or interesting things that popped up during the implementation?
I think for us, we had a lot of positive surprises. We started with some expensive sensors when we first got into it, and then when we got into I'm going to say cost-effective ones, the surprises were kind of where the savings were. We thought we might be monitoring some equipment as far as a weekend shutdown. And then we had surprises of, equipment that were drawing power that maybe shouldn't have been, a transformer that wasn't disconnected, or a capacitor that was faulty, or finding, on a thermalator, a cooling valve that's stuck open, so it's always drawing heat. So a lot of those, positive surprises. And in the end, those are the ones that help us sell the monitoring and justify the monitoring. So some good surprises. As far as challenges, I think is getting the team engaged. Once, for us, a big thing was, the maintenance team. Once the maintenance team saw the benefits for them of the metering, then they became a big sell. So small challenge in the beginning, but a big win later on.
All right, great. Those are some excellent, some nice surprises that came along with it. Joking, we're almost out of time here. Did you have anything to add on, anything unexpected things that came up during implementation?
Honestly, nothing I can really think of right now. I think partially because we've only started migrating a few of our facilities over. They've so far been pretty straightforward. Thankfully, so yeah, nothing so far, but I can kind of foresee, and I'm a little worried about the integration of maybe some of our older meters from some manufacturers, just because sometimes you kind of need that manufacturer support if like the controls contractor is not familiar with the meter, for example, and trying to get the points over to the system as you're integrating them. But yeah, nothing so far, thankfully.
Okay. All right. Well, fingers crossed.
Yeah, I just want to share something real quick. Jason reminded me that when he was talking about the surprise savings from unexpected areas, early on in the install of our system, there was a a spike in our water usage, which it flagged up. But to be able to find it, the plant had a map of their water system, where the valves were and where the submeter was. So because they had that map, they were able to identify which parts of their entire system the submeter related to, and that really narrowed down the search area, and they were able to find it within a day. So I would say that having a map of your electrical wire diagram, which circuits are on which submeters, and similarly with your water, is key to getting the rapid turnaround from those alerts to identifying where the real problem is.
And I could see that going to Jason's point about getting maintenance on board, where it's like, oh, we found this in a few hours rather than a week spent trying to figure out where this leak was coming from. All right, great. Well, I'd like to thank you so much to all of our panelists for joining us today and sharing their time with us. It's great learnings, great to hear about their experiences, and hopefully all the attendees got something out of it. As always, we do really value your input and your feedback on these workshops. So please take the time. You can use your phone with the QR code, or Fatema has dropped a link into the chat. There's just a couple of really short questions, and we always really value this feedback and take it to heart to help us improve these sessions. So I'm going to pause for 30 seconds while people fill that out. Maybe not full 30 seconds, but hopefully you've all gotten started on that. There's a couple of things I do want to cover first. Through Save Energy, we do have free coaching support advice available. So if you want that on any of the topics that we've had, you can contact training support at iuso.ca or post questions on the learning platform, the energy management learning platform at emss.goldfin.ca. You can also use that discussion forum on there to keep the conversation from today going if you have any further questions for our panelists. The other thing I want to announce is that the 2024 Energy Management Excellence Awards by Save on Energy are coming up. I know we have a lot of excellent energy managers on the line here, including some previous award winners. So I want to make sure everyone's aware of this. The nomination deadline is coming up soon. So please submit your nominations, your self-nominations, to get recognized for all the great work that you as energy managers are doing. The submission form for this initial deadline in June, it is a brief short form, and then that'll lead to a short list, which has sort of like, we'll get more information from nominees at that point. So it's a easy nomination to get started with. So please go and check that out. The link for that, Fatema, will drop in the chat as well. There's a page up on the Save on Energy website related to that. And then our final thing for today is one question that I'm going to leave you with. So please, before you leave, go back to Menti and let us know what's one potential data tracking system. No, wait, that's the wrong question. Sorry. In the chat, since that was the wrong question, what's one key takeaway from today that you're going to look to act on in the next week or two? So if you could just let us know in the chat what your key takeaway from today's conversation was on your way out, then we'd appreciate that. Thank you all for joining us today, taking the time. Really enjoyed hearing the conversations from our three panelists, and have a great rest of your week.